Hello, today we're going to be looking at bisectors. And in order to look at bisectors, we really need to do a little bit review when it comes to midpoint. Now remember what we learned about midpoint last time. We knew that midpoint is going to be the point exactly in the middle of a segment. And so if M is the midpoint of AB, it means that from A to M is going to be the same length as from M to B. Now that allows us to solve problems like this. If K is the midpoint of AB and KB is equal to 16, what is AB? Well, I know that K is going to come in the middle of AB. I also know that from K to B is 16. Since we have midpoint, and notice this is a key term, so make sure that you adjust your picture whenever you have a term to fit that. If I know that that's a midpoint, I can add these little equal markings, and therefore I know that the distance from A to K would also be 16. And to find AB, I merely need to add these together, giving me a total answer of 32 units. Now you might have just been able to glance at this and say, well, this is halfway, so I just need to multiply it by 2 to get to my final answer of 32. And that's grand. If that does not come automatically to you, don't be afraid to draw a picture. That always helps people out. So we can also solve problems like this. Let's say P is a midpoint of SD, and the coordinate P, that's what this lowercase means, is at -2. And PS, the distance between P and S, is 10. What are the coordinates of S and D? Well, this is a number line problem because it's talking about coordinates. And so if I make myself a number line and I'm going over here and I'm at -2, I've got all these coordinates up here. And I wanted to find, well, if I only know where P is, where are my other 2 points going to be? Well, I'm going to keep in mind that PS is 10. That means I'm going to have one coordinate that's 10 away on this side. But since P is going to be the midpoint, there's going to be 10 units away on the other side as well. So I just need to figure out, well, what's going to be 10 away to both sides. And I can do this with, of course, some basic algebra. I can take my original coordinate and add 10 to it. That's going in the positive direction or towards the right. And that gives me the coordinate of 8. So I know that either S or D is at 8. I can also go in the negative direction or towards the left and say, well, I can take my original midpoint, -2, and I can subtract 10 from it, and that will give me my other coordinate of -12. And so that means S or D is at -12. And I have my 2 coordinates just by looking at which things are 10 away from -2. Now the last one's going to take a little bit more thought, and that is to do with the coordinate of a midpoint of a segment. Now, when you think about midpoint, you can think about it as the exact middle, but you can also think about it as the average between these 2 points. Because if these 2 are 2 extremes, let's say like this is a score of 1 and this is a score of 6, the average is going to be exactly in the middle. So I could do 1 plus 6 to get 7, and I could divide that by 2 to get my final answer. So 7 over 2 would give me my 3.5 here. And that ends up being our formula for the coordinate of a midpoint. You are going to take your ends, A plus B, and divide them by 2, and that will result in your new coordinate. Now, of course, with numbers like 1 and 6, we can easily find that on a number line, but if you have coordinates like this, it might take a little bit of work. So you're going to get P and Q are endpoints, put them into your formula since you're looking for the coordinate of a midpoint to get -15.206 plus our Q, 7.84, and divide that by 2. Please don't forget, if you are doing this on your calculator, you will need parentheses around the top of the fraction because that's considered like a hidden brackets or hidden parentheses. Go ahead and type that in. You should have an answer of -3.683, which would be the midway point between these 2, or the coordinate M. Now what we're going to do is we're going to switch over to looking at bisectors. Now bisector you can kind of think of as two sections. That's what the word basically means, a bisector or section. So what it's always going to be doing is splitting things into two. And not only does it split things into two, it will split things into two equal pieces. So when we're talking about a segment bisector, it's going to split a segment into two equal pieces or intersect a segment at its midpoint. Now here I'm just going to eyeball it. If this is AB and I have something coming exactly through its midpoint, it would be like this. Now notice that with a segment bisector, we can have it coming at any angle. So that would be a segment bisector, so would this guy through the middle. As long as it's coming through the midpoint, it doesn't matter at what angle it hits. We do have a special bisector called the perpendicular bisector that is only going to bisect at a 90-degree angle. So that means there's only going to be one possible perpendicular bisector to a segment because only one line will go through the exact middle at 90 degrees. So that's going to be our special case. But it's always good whenever you have a bisector to remember that you can add these lines if you know that, like PQ is a bisector of AB. And that means that with these lines we're able to set up an equation and solve for missing variables or missing lengths, because I know that these two things will have to be even if PQ is a bisector. And that's a normal problem we can solve. We can add 21 to both sides to get 39. We can subtract 9x, and that will give us 3x. And then I can take 39 divided by 3 and end up with x is equal to 13, our final answer. I can also do problems that are word problems, where AP is the perpendicular bisector of SD, and it's always good to have that sketch going as you're reading through. Watch for those key words. Bisector and perpendicular tell me that I have to draw this in exactly in the middle and at 90 degrees, so I want to put that information into my picture. I also know that P is on SD. So A is somewhere on this line, and P has to be both on the bisector and on SD, since it's mentioned here and here. Well, that tells me enough information to solve this problem, because I know that SP is 14. I also know that DP, from here to here, is 6x plus 2. And if I want to find the overall length, well, for one, I don't even need to do any math. I could solve for that x, but I already know that the halfway point is 14. So 14 plus 14 is going to give me 28, and I'd actually be done at that point. The x is just there to throw you off a little. Don't be afraid of looking for shortcuts. We all like them. Now, last but not least, we have what's called the angle bisector, and unsurprisingly, since it is a bisector, it's going to split an angle into two equal pieces. Now this, of course, is a working definition that is not the official definition of a bisector, but it is something that we can use to help us understand bisector. So if I'm making this ray, and bisectors for angles will always be rays, it's going to start at A, it's going to head towards another point, which I'm just going to call D, and it's going to split these into two equal pieces, so there will usually be equal markings down here. Now, sometimes it will just tell you this in the problem. So for instance, if I have find x, if AB is the angle bisector of CAD, I'm going to have to draw on those markings. And notice that this problem actually would not be solvable if I didn't know that AB was the angle bisector, because I don't have an overall length, and without knowing that it's a bisector, I wouldn't know that these two things were equal. But since I do know it's angle bisector, I can put those little equal marks, which means I'll be able to put 33 equal to 4x plus 1. So don't forget to look for those. Those are going to give you your formulas when you're running stock. I can subtract 2 from both sides. This is going to give me 32 is equal to 4x. And divide both sides by 4, and you have your final answer of 8. And that would be our answer for x. I guess it's not actually my final answer because I'm looking for the angle CAD. So CAD is going to be the full distance here. But again, I actually could have skipped all of this, because if I know that this is an angle bisector and this is 33, then this must also be 33, giving me a total distance of 66 degrees. And that would be the end. Homework is listed on Classroom. Check it out.